Alright, hello. We're going to be looking at right angled triangles. So there you go. It's not a spelling lesson, is it? Right angled triangles. So right angled triangle, there's lots of different types, but we have a triangle here, right, and this is the notation for right angle, which means it's 90 degrees. That means that this angle here and this angle here should also add up, or do add up to 90 degrees as well. So one other thing with the right angled triangle is that you can identify the hypotenuse, which is always opposite the right angle. The hypotenuse is always the longest. It's always the longest side in a right angled triangle. And usually we call this H. Okay? So if we have another right angled triangle, let's say something like this, and we call this angle here theta, we have the right angle here, which means that this is the hypotenuse. So this is the hypotenuse, which is opposite the right angle. Now, because let's say we're interested in this particular angle, it's called theta, this side here would be called the adjacent, because it's next to the theta, and this one here is the opposite. Yeah, opposite. So if we look at the opposite and we just call that O and we call this A, then any right angled triangle you could draw, just like this. Here's my right angle, this would be my hypotenuse, and if this one here is your theta, then this would be your A and this would be your O, being the opposite to the angle that we're interested in, or that we've labeled. Okay, so there's a few questions. So if we just did one more example, we just drew some random triangle here. Pretend that's a right angle. If I label that as a right angle, it's 90 degrees. It doesn't even need to look 90, but because it's labeled 90, this becomes the hypotenuse. And if I put angle alpha here and angle beta and angle alpha, the opposite side to beta would be this one here. This is opposite to beta, and this is adjacent to beta. If we're looking at alpha, this is the opposite to alpha, and this is the adjacent to alpha. So now that we've covered which is the hypotenuse, adjacent, and the opposite, I can show you how to solve a question like this. Before we get into solving an actual question, I want to just go through briefly about trig ratios. Trig ratios, a ratio being a ratio of something, any number on another number. So P on Q, that's a ratio. We have, let's rub that out. Alright. So we have the right angle here, which means that this is the hypotenuse. And if we label this angle here theta, then we have a function that says sine of theta equals the opposite angle, so the length of this, the opposite, which is the opposite, divided by the hypotenuse. So if we get this length and divide it by this length, it becomes this value, and that's determined by the angle. Another one, cos theta, is the adjacent divided by the hypotenuse. So we have the adjacent, the length, divided by this length here. And the last one, tan, which is the tangent theta, equals the opposite over the adjacent. So it doesn't use the hypotenuse, it gets the opposite length divided by this length here. So these are the three trig functions that we use. Now tan theta can be also seen as sine theta on cos theta. And if we substitute in these ratios into here, we have opposite over hypotenuse divided by adjacent over hypotenuse, which, if you do your fractions, this becomes opposite hypotenuse, and then a hypotenuse here, and adjacent. These two actually cancel out, which you end up with opposite over adjacent, which is the same anyway. So I just showed that to you just so you can see how that works. Alright. Now, to solve an actual question with an unknown, we can look at this here. Where are we? Here, okay. So we've got a triangle, right angle, and if we're told that this is 30 degrees, so our theta equals 30 degrees, and this is 15 centimeters, and x is our unknown. This is what we want to find. So we know the angle, we know the hypotenuse, so let's write this down, but we don't know the adjacent. So our theta equals 30 degrees, hypotenuse equals 15 centimeters, and our adjacent equals unknown, we don't know. So we can use sine, cos, or tan to solve this. So the next thing to look at is what do we have, and compare it with these here. So we have a hypotenuse, and an adjacent. So our cos has a adjacent and hypotenuse. There's no other one here that does that. So we'll use cos theta. So cos theta equals adjacent over hypotenuse. So we have, this turns into cos of 30 equals, is this in camera? Yes. Cos of 30 is the adjacent, which is x, over 15. Now we want x to be on its own, so we move the 15 over to this side, or we can multiply both sides by 15. So we have 15 cos 30 equals x. Now, a bit of calculator here. Make sure you've got it in degrees, because this is in degrees. The cosine of 30 is this value, times it by 15, which is this, and this is the value for x. So let's call that 13, just for round numbers, equals 13 centimeters. So really, this triangle is 30, 13, and 15. Cool, and that's it. In the last question, we used a right-angled triangle and the length of a side and an angle to find this unknown. So we're finding a side. We can also use sine, cos, and tan ratios. We can use these ratios to also find an angle. So let's say we have this triangle, right angle. Again, this is the hypotenuse. And the unknown angle is theta. And we know that this is 7 meters, and this here is 4 meters. So now we're using two sides. One of these trig ratios to find this angle. Now we have the theta, this is the adjacent, and this is the opposite. Because we've been given the opposite and adjacent, means that we use tan, because this is opposite over adjacent. These two here use the hypotenuse with the adjacent and opposite, but that's, so we're going to use tan for this one. So we have tan theta equals opposite over adjacent. What this really means is that the tan of the angle equals opposite 4 divided by 7. But we want the angle. So what we have to do is we have to operate on both sides with inverse tan. So we would go tan of tan theta equals tan 4 on 7. Now some maths happens and these two cancel out and just become theta, and then we're left with inverse tan 4 on 7, which when we use the calculator, we go shift tan, and you have inverse tan here with the -1 of 4 on 7, and then we go equals, and this equals 29.7 degrees. And that's how we found the angle using two sides and the tan ratio. Cool, that's it. Okay, so here we have another triangle, again right angled triangle. The hypotenuse is unknown. We have been given alpha and beta, so the aim here is to find everything that's unknown. So when this is finished, this will be finished when we know the value of x, alpha and beta. Now there's no direct way, well, there's no one way to do this. It's really up to whoever's doing it and what maths tricks they like to do. You could find x by simply using Pythagoras. You could say that, let's say, x squared equals 3.5 squared plus 4.8 squared. So I can't do this in my head. 3.5 squared plus 4.8 squared equals 35.29. So this will mean that x equals, so that's the square root of that, 5.9. Okay, so we used Pythagoras to find x. Let's say that how would we do this? Alright, so yeah. Alright, so let's say we want to find beta. So beta, so we want to find the angle beta. We know that x is 5.9, and so beta's adjacent side is 4.8. So the A equals 4.8, and the hypotenuse is 5.9, which we worked out using the Pythagoras theorem. 5.9. So we've got adjacent and hypotenuse, so that means we would use the cos ratio. So cos theta, well, not theta really, it will be cos beta equals adjacent over the hypotenuse. So 4.8 divided by 5.9. Now we want to get beta on its own, so we act on both sides with the inverse cosine, which is cos minus 1 of cosine beta equals inverse cos 4.8 on 5.9, and this turns into beta equals, let's just do this on the calculator, inverse cos 4.8. Okay, what we do first is we work out this value, 4.8 divided by 5.9. Now that's a number. Then we go inverse cos, and we put our answer in, and we end up with 35.5 degrees. 35.5 degrees. Okay. Now that we know what beta is, we know that that's 90, we can just go to alpha equals 90, take beta, which means that it's 90, take 35 point, whoa, off camera, look at that, 35.5 equals 90, take 35, 90, take 35.5 equals 54.5 degrees. And that's done. So we've got, it'd help if I drew it the right way. Alright, so here, 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 this turns into 3.5, 4.8, 35.5, 54.5, and 5.9. We know everything about the triangle. Done.